Welcome back, Nature and Code. We're in chapter 5 and we're implementing a spatial model here in JavaScript. So we just implemented this run generation function here and it is finished. However, it is currently calling two functions that are not defined yet. Pick mating partner, which should pick a mating partner in an allowable mating neighborhood given a current location here defined by I and II, and then producing an offspring from the current individual and that mating partner. So in this video, I would like to implement this function here, pick mating partner. So how should this function work? Well, let's take a look. So we have our grid, and we said that we would like to have a situation like this where we have an individual and this is the mating neighborhood. So how do we define this exactly mathematically? Well, it's actually quite simple. So let's make an example. Let's say we have a mating distance of 1, max mating distance of 1, and we have a situation like this. We have a focal individual here in the middle, and we know that this is the neighborhood here, the allowable mating neighborhood. So for example, we could be in a situation here where we are at, I don't know, coordinates, say 5, 4, or something like that. So up here, for example, we would be at 4, 4. Down here, we would be at 6, 4. Correspondingly, over here, we would be at 5, 5, or 5, 3. And here we would be at 4, 3, and here we would be at 4, 5, and correspondingly down here we would be at 6, 3, and here we would be at 6, 5. Or another way to think of this is that, if we have more generally I, then here we are at I plus 1, I, and here we are at I minus 1, I. Here we are at I plus 1. Here we are at I minus 1. And then we have these 4 cases here. So in this case, both are minus 1, I minus 1, I minus 1. Here both are plus 1, I plus 1, I plus 1. And here we have I minus 1 and I plus 1. And correspondingly here we have I plus 1, but I minus 1. So these are all allowable cells. So what we need to do is basically we need to say, well, starting from an I or an II, we have a range of allowable values. And so if we think that our new coordinates or the coordinates of this chosen mating individuals are going to be defined by J, JJ, then the following will be true for this particular situation, namely that J itself should be not smaller than I minus 1. So it should be larger than I minus 1, or at the minimum it should be equal to I minus 1. And so this would be the maximum value here to the left. And conversely, it should be smaller than I plus 1, or equal to I plus 1 as the maximum value. So it should just be within that range, including those two minimum and maximum values. The same is true for JJ, right? The exact same thing, except here we would have I minus 1 as the minimum value, and here we would have I plus 1 as the maximum value. And now this is true for D equals 1, but of course we could just replace this with D, more generally, so that J would have to be within I minus D, and I plus d, and jj would have to be within the range ii minus d and ii plus d. So these are sort of would be the minimum value here, and this would be the maximum value here. So, and you see this work out quite nicely here, right? So for example, here our I is 5. And so we know that the I that we choose, or the J that we choose for the mating individual, should be somewhere in the range of I minus 1, which is 4, and I plus 1. So somewhere, 4, 5, or 6. And the same is true for II. It should be, II is 4. So JJ should be somewhere in the range of 3, 4, 5. And so what we have to do is we simply have to implement this method given an I, given an II, and given a max mating distance. Give me a random integer, so a whole number, of this allowable range here. So let's go ahead and implement this in JavaScript. Go back to our code. So let's define here this function pick mating partner. Function pick mating partner. And as we said down here where we call this function, we actually pass two variables into this function, right? We pass in the variables I and II, and so I'm just going to call those arguments I and II as well. Although, again, you can name them whatever you would like to. Good. So what we have to do is we have to come up with a J, and I'm going to outsource that to another function, which I'm going to call get random int. So this is this function that should calculate a random int based on a minimum and a maximum allowable value. So what is the minimum allowable value? Well, as we just said, this is I minus max mating distance. And the maximum value is going to be I plus max mating distance. Just going to add a space here to make this look a little nicer. And the exact same logic will apply for the JJ, so for the other coordinate, except that here, of course, the minimum value is going to be II minus max mating distance, and the maximum value is going to be II plus max mating distance. All right, so let's go ahead and implement this function. This is going to be a very generic function. Get random int. So here, again, I'm expecting two arguments. Now I'm just going to call those min and max, because that's what they are. Those are the minimum and maximum allowable values. Okay, what does this function look like? Well, keep in mind, we would like to have a random whole number given a minimum and a maximum. So, for example, if our minimum is 4 and our maximum is 6, it should be a random number, either 4, 5, or 6. If our minimum were, 3 and our maximum were 7, it should be a random number from the set of 3, 4, 5, 6, 7. How do we do that? So here's how we do that. We will have to use, of course, as always, our math random, because that's the only way to even get started with random numbers in JavaScript. Math random is nice, but has two problems here for our purposes. The first problem is that it returns floating point numbers. What we want, though, are full numbers, integers. The second problem is that it has a wrong range. It goes from 0 to 1, but we might want something like from 4 to 6. So let's fix those things. So first of all, let's fix the range thing. So 0 to 1, We will need to blow that up, right, that range. It shouldn't just span an interval of 1. It should indeed span an interval of, um, typically a larger interval. Let's say we would want a random integer between 7 and 13, for example. So these would be the min and max values. So the range would be 6, right? Because we have 13 minus 7. So we need to multiply this here with the difference between max and min. Now, if we just left it at that, there would be a slight problem here. We will eventually have to round these numbers down using the mathfloor function because we don't want floating point numbers. However, mathrandom won't include 1, and so this maximum value won't be included. So, in our case here, max minus min with the examples of 13 and 7, this would be 6. Mathrandom times 6 will be somewhere between 0 and 5.999999. However, we would like to have 6 included. So we need to add 1 here to this term. And then we can go ahead and round this whole term down. So let's put this in parentheses and pass this as the argument to mathfloor. So this term will now give us a random number including 0, 1, 2, 3, 4, 5, and 6. However, we're not done yet. This is not quite what we wanted. We have the right range here, and it gives us integers, but it starts at the wrong number, right? It starts at 0. It should start at 6. And so, obviously, we will need to add min. Sorry, it should start at 7. 7 is the minimum. So, but in any case, we need to add min to this to sort of shift this range here to the correct minimum. And that is it. So, if you take a little time to wrap your head around this, this is quite okay. Unfortunately, JavaScript doesn't quite come in with these built-in functions, but so there are libraries out there that provide this. But I think this is a good exercise, just showing you that what these libraries would do is essentially just a simple one-liner, and it's good to think through this, how exactly this works, and that you see that you can really do everything from scratch in JavaScript. So now that we have our getRandomInt, we can use this here. GetRandomInt, we're passing a minimum value, passing a maximum value, and this will then generate the correct indices for the mating partner. Now we're almost done. There is one problem left here. What is this problem? Well, the problem is it has to do with the borders, right? Keep in mind, we were looking at a world that has borders, but we don't want borders. If we have an individual here and we have a given mating distance, then we would like the mating distance not to just end, or the mating region not to just end here, but simply to continue over here as if the space here were wrapped around. And so if you leave here, you enter here right away. Now at the moment, we don't do this. So when we're here at this location, and in the case of a grid length of 10, we would here be at index 9, for example. Now we would add 1, and then we would of course here be at index 10, and that doesn't exist in an array of dimension 10 or of length 10. Correspondingly, if we're here and we would move 1 to the left, we would be in a negative index. So we will have to fix this. How do we fix this? Now, thankfully, it's not a problem in most of the cases, but it's a problem in many cases, and JavaScript would throw an error at the first case. So here's how we fix this. Think about the array. So let's say you have an array here of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or rather, these are the indices of this array, okay? So it could be an array like this. So these are your indices, and say you're at index 5, you want to move one to the left, well, you're simply going to increase the index by 1. You want to move one to the right, you want to move one to the left, you're simply going to decrease the index by 1. The problem is if you're here, right, if you increase the index by 1, you're going to end up with an index of 10, and that would throw an error. Or vice versa, here you would end up with an index of -1, and that would throw an error. So the trick is to basically bend this array here so that it looks something like this. Yeah, doesn't exactly matter how many I show here, but basically, you know, if this were 9, then here this should be 0 right away. So as you move out of the, you know, seemingly, you know, of the seeming border, you actually just move right over here to 0, and vice versa. If you move out here to the left, you will just re-enter here on the right. How do we do this? Well, simply think of, you know, adding the array continuously over here as well. So this would again be 0, 1, and so on, and adding it here as well. You know, this would be 9, 8, 7, and so on. And so here the calculated index would be -1 or -2 or -3, and here would be 10, 11, and so on. So now what you have to do is basically you just have to map this value, which wouldn't work, would throw an error, to a value that will work, and that is the correct one in this model. Okay, so you would have to map -1 to 9, -2 to 8, -3 to 7, or 10 to 0, 11 to 1, 12 to 2, and so on. How do you do this? Well, it's actually quite simple. You can see here this value, if it's larger than it should be, all you have to do is you just have to take this new index that you generated, and you basically have to subtract the length. So in this case, you would have 11, and you would just have to subtract 10, and of course you would get 1. And this is the correct mapping, or 10 minus 10 would be 0, 12 minus 10 would be 2. So this is the correct mapping over here. Over here it's slightly different. For example, you have -1, you want to map this to 9. Well, the trick is simply to say, okay, give me the new index that I calculated. That might be wrong. Now I'm going to add the length to this value. So for example, -2 plus the length is 8, or -1 plus 10 is 9, -3 plus 10 is 7. So the mapping here basically over here is simply -10, over here the mapping is +10. So you just have to figure out whether you're on this side of the problem, so to speak, or on this side of the problem. So let's go ahead and implement this in code. So what I would like to do here is, once I've calculated this value j, which is potentially wrong, I basically just need to pass it. I want to pass it through this extra function that just takes a look and says, is this an okay value? If yes, I'll just return that value. If not, then I'll return a correct value. So what I'm going to do is I'm going to pass this through a function that I'm going to call get bounded index. That gives me the correct index given the bounds. So I'm just going to pass j here through this function, and then it will return the correct value for j. And I will do the exact same thing with jj, of course. So jj, I will pass jj through this get bounded index function. So let's go ahead and implement this function get bounded index. Oops. And this function takes a value as a parameter, and I'm just going to call this index because that's what it is. It is an index. Now I'm going to set up here this bounded index, a variable that I'm going to initialize with index. And then I'm going to just return bounded index. And indeed, most of the time, this is exactly what this function will do. It will just look at the index and say, yeah, everything is fine, return it. Return exactly this value. However, there are these two cases, right? So we just need to test for these two cases. So if the index is too small, if it's negative, then as we saw, all we need to do is we need to say, okay, the bounded index is going to be whatever we have here plus the grid length. Yeah, this is what we developed just on the slide before. If we're on the other side of the problem, so if index is too large, if it's larger than or equal to the grid length, then we're on the right-hand side of this problem. And then, as we saw, what we need to do is we simply need to subtract grid length from the index minus grid length to get this proper bounded index. And then here, once we return bounded index, it was either correct from the get-go, or if it wasn't, we've now fixed it. And that's pretty much it. So now we have these two variables. They are within the correct mating distance. They are the coordinates within the correct mating distance, and they are correctly bounded in case you know, they're somewhere on the other side of the grid. And now all we have to do here is to simply return the corresponding individual at these coordinates. And this is our pick mating partner function. And in the next video, we're going to implement the other function that we were missing, the get offspring function. So I'll see you in the next video.